two, one, and go.
Hello. I'd like to welcome you to our fourth session in the series Miami Do You Love Me, the Miami Beach Urban Studies course. And today we're very glad to welcome Colin Ford of Morphologic. Colin is a long-standing friend of ours and collaborator. He is also the co-founder of the extraordinary firm Morphologic, a kind of combination of artistic practice and marine biology. In many ways, the coral of Miami represents Miami very well. This extraordinary, exotic, exquisitely beautiful ecological system that is itself extremely fragile and at the mercy of global warming and so on. Today's session will be having Colin presenting, and after Colin, we'll have some presentations from brief presentations from Eric Goldemberg, who has been collaborating with him, and then Philippe Morel. So Colin, welcome. It's great to have you here. Thank you.
Yes, thank you so much for having me, Neil. So, you know, I guess to start out, my name's Colin Ford. I am a marine biologist by training. I studied here in Miami. And at some point in my academic career, I realized that these organisms that I love so much were every bit as aesthetically beautiful and colorful as you'd see in the art galleries that were, when we were Miami was in the midst of a contemporary art renaissance, more than a decade ago. And I realized that there really wasn't a lot of corals didn't really come up in the iconography of the city, and yet, we are a city that is surrounded by coral. And this is where the birth of Coral Morphologic began, with this sort of a literal intersection of humans overlapping with corals, and really as a platform to try and explore the similarities between, we as humans, we like to think of ourselves as very intelligent, and can control our environments. And then, we have corals on the other end that I think most people, their basic understanding of coral, if they have an understanding at all, is not fully well understood as to what a coral is. And they're generally presented as being so delicate and helpless that it almost seems like, there's nothing that they could teach us. And so Coral Morphologic has really been a platform to explore kind of the ways in which corals can teach humans how to be better global citizens. I guess that after 13 years of doing Coral Morphologic, that's what really excites me. And here in Miami, we have a project, our big project of the last year has been called the Coral City Camera. It's an underwater live streaming camera that is we're currently at low tide here, but this is at the tip of Port Miami, and it's all basically a human-made environment where these boulders that were put down to protect the shoreline of the port itself about 10 years ago have now become naturally colonized by marine life, corals, tropical fish, et cetera. And so, as a scientist, I recognized that this was a very interesting opportunity for us to see how nature and human infrastructure overlap, and in some cases can benefit each other. And so this camera has been a real, I'd say, a very successful project over the last year, especially during the pandemic. We have people all around the world that are tuning in, and they're realizing that Miami has so much more under the water than perhaps anyone ever imagined. I think that most people tend to have this idea of Miami, and especially, last summer with a lot of news stories about the health of Biscayne Bay and decline, which is very real. But at the same time, there are these places in and around Miami that are almost verdant oases of life. And we want to from a scientific perspective, study them, understand how this works. We're thinking about resilience. of these organisms and the evolution that it might take for an organism to live in a place where you'd never imagine it. But then, also the aesthetic possibilities and the technological possibilities of being able to access these environments. For instance, it'd be very difficult at this juncture to bring a camera out to the Great Barrier Reef, to someplace very pristine. How do you get it onto the internet? How are you get reliable power? How are you going to clean it? So there's all of these things that, sort of Miami has offered us an opportunity to explore this intersection. And I want to kind of step back and frame, I guess, the context of my talk really kind of in the context of corals as sort of really the first city builders of planet Earth. The corals are themselves architects, and a coral reef is essentially the combined output, the architecture of thousands of corals over thousands of years, producing these highly dynamic environments. And you look around at other environments around the world, or you think about terrestrial environments, and the one thing that a coral reef has that many other environments don't have is three-dimensionality, right? So typically, if you're dealing with a terrestrial environment, you just have the land. We've got gravity, of course, we've got birds, and we have trees, and there's a lot of life that could take place there. But in the water, the water column itself offers a medium in which things are much more easily able to move around, and corals are building these structures that essentially are like high rises, which contain life, which is really what a human city is. And so I think that it's as in the context of architecture, and as students of architecture, it is perhaps a very eye-opening opportunity to kind of look at the ways in which cities and architecture, how it serves other life forms, and perhaps by understanding, sort of coming at it from a different perspective entirely, then we're going to maybe have a better understanding of how architecture can serve humanity. So that's kind of how I want to kind of put things into perspective. And in order to really kind of understand the bigger picture, of course, we got to go back and we got to start at the basics, which is really just kind of like, what is a coral? Where does a coral start? Where does a coral end? Where does a coral reef start? Because it sometimes it can get quite confusing. And so going to go back and we'll do a little Coral 101, and we'll utilize, this is basically information that you can have access to. NOAA, which is the National Oceanic and Atmospheric Administration, has really put together a good sort of overview. I'm going to kind of do it in my own words, but when you're talking about a coral, really we're talking about a colony of organisms. And so corals, they've been around on the planet for 600 million years, which is 10 times longer than the dinosaurs, or since the dinosaurs went extinct. There have been 5 major global extinctions that have taken place during the time in which corals have been on planet Earth. And so, that tells us something about evolution and resilience, and perhaps, that we have something to learn from them. Because when you stop and you think about sort of humanity's history of city building, we've only been building cities for about 5,000 years. And that's about an average age of a coral reef. So corals have been doing this a lot longer than we have, which is, again, a reason for us to perhaps look to them for inspiration, since they've got a lot more experience than we do. So corals are related to jellyfish. So when you look at this picture on my screen of a very archetypal coral, you can very kind of easily see that this looks sort of like a bunch of jellyfish, the undersides of jellyfish. You can see the tentacles. You can see that they're radially symmetric. And you can see that there's a slit in the middle, which is a mouth. It's also anus, and they have one orifice. They're radially symmetrical. But unlike a jellyfish, which is free floating, corals are cemented to the substrate, and they produce a skeleton out of limestone. So, and that's something to think about. Here in South Florida, when we're building with concrete, all of the concrete that's being mined out in the Everglades in South Florida, at one time or another came from marine organisms, whether it's coral or smaller organisms, shells, etc. So, for instance, Coral Gables is called Coral Gables because the rock that was used, this keystone, is coral fossil that was mined down in the Florida Keys. That's why it's called keystone. And it is, of course, what has given the city of Coral Gables its iconography. And you can see this keystone throughout architecture in South Florida. But again, they're creating basically a cement, a limestone skeleton. And as they grow, all corals start out as sort of a single polyp. So when they settle out onto the substrate, they go through metamorphosis. They lay down their skeleton, and that's when they start to build their colony. So what you're looking at on the screen right now are a colony of polyps. So they're dividing asexually. And of course, when you divide asexually, this is cloning. And so one polyp becomes two becomes four. And over time, you wind up developing these colonies. And that's when we talk about a coral on a reef. We're really not talking about the individual polyps. We're talking about the whole colonies of these coral polyps that create these skeletons and structures that we identify as corals. And every coral species has a little bit different way in which its skeleton and the geometry of the colony develops and the shape that it creates. Everyone is unique, and scientists look at they look at the colony, and they're able to determine species based off of these differences in how the skeletons are formed. And so, this is really kind of the foundation of a coral reef. It starts really with just a few corals, and as they grow, they create these mounds, these colonies that eventually die. And when they die, they leave behind this limestone skeleton. They leave behind this piece of concrete, essentially, which then becomes new real estate. It becomes new opportunity for a new coral polyp to settle and to begin a whole new colony, or you can have multiple species that are coming and growing on the same old dead coral head. And if you do that again, year after year, over hundreds of years, you wind up creating these really massive structures that we call reefs. But corals wouldn't be able to do this on their own without extra assistance. And this is one of the things that you see on the reefs again and again and over again, is this idea of symbiosis. So symbiosis is something that happens, it's really like a form of mutualism, where you have two organisms that work together kind of and help each other out in a way. So it's a form of like 1 + 1 = 3. And coral reefs, when I'm talking about coral reefs, I'm talking about tropical coral reefs. There are corals that live in cold, deep water, but for our intent and purposes, when we're talking about corals and coral reefs, I'm talking about the traditional tropical shallow water coral reefs. And the reason why these reefs are restricted to the tropics and the subtropics has to do with the fact that they are hosting a photosynthetic algae in their tissue, which gives them extra power during the daytime. They're solar powered. I mean, they're incredible animals, because of course a coral is an animal, And here they are, they have the symbiosis with an algae that they let live in their tissue during the daytime. They're basically soaking up the rays of the sun. They're getting the energy that the algae produces, and it allows the coral to build these structures a lot faster than if they were just catching food and plankton in the water on their own, which is what they do at nighttime. So when there's no sun, they can't be photosynthetic anymore. And then this is when the jellyfish side of a coral comes out, and the tentacles will come out, and they eat the plankton that usually comes out at nighttime. So you're dealing with an organism that is like multitasking all the time, which is, again, I think about corals. They're ancient organisms. They've been on the planet for tens of millions of years, but yet in many ways they're extremely modern, and in many ways sort of human life is only now just catching up with our ability to understand and appreciate kind of some of the ways in which they live. Because when you're a coral, you're cemented in place. Once you've gone through your metamorphosis, after you've settled out as a tiny baby larvae, you've kind of made your choice, and you either get lucky and you're in a place that has like anything in real estate, location, right? You need to be in a place that's getting good sunlight. You need to be in a place that has temperatures that aren't too hot, not too cold. And so this is why you only find coral reefs pretty much in the subtropical and tropical regions, because during the winter time you don't get enough sunlight in the winter. And also corals need clean water, clear water for the sunlight to be able to reach them so that they can do the photosynthesis. So it restricts corals to a very small area of the planet. I think coral reefs maybe cover 1 to 2% of the planet's the ocean's surface, but they're home to up to 25% of marine life at some point in their lives. So it's an incredibly important and diverse ecosystem that for its size has an outsized influence on oceanic and earth health. So this idea of symbiosis and zooxanthellae is a really important one. Perhaps you've heard of things like coral bleaching. The corals are bleaching, the reefs are bleaching. So what happens when a coral bleaches, it doesn't necessarily mean that the coral has died, but this relationship of the symbiosis with the zooxanthellae is disrupted because the water gets too hot usually. And the coral has to expel this algae, and then no longer is the coral able to get the energy that it normally does. When it expels the algae, it loses its color, it looks bone white, and if conditions don't return to normal, the coral can die after several months. So, of course, one of the biggest drivers of coral bleaching is global warming, and it's something that is increasing in severity and intensity around the world on coral reefs. So this is really kind of like the big overall existential threat to coral reefs, is global warming and CO2 emissions, which of course these are existential threats to all of us. But corals and coral reefs are really kind of they're kind of considered the canaries in the coal mine, because they are so sensitive, and they show their sensitivities kind of before other things begin to collapse. But it's important to remember that we're all in the same coal mine. So if if the corals are sick and struggling, then that means that really everyone's all in that same boat. And so, besides humans, corals are pretty much the only animals on Earth that build colonies you can see from space. So, when you look, you can see the Great Barrier Reef from space. And so this is, again, this idea that corals have been building these cities for much longer than we have been building these structures and these human colonies. And again, it starts from a small grouping of corals that over time grow. It usually takes about 10,000 years for a coral reef to grow. Now, coral reefs grow relatively slow. Actually, they grow very slow. millimeters a year. But an individual coral can grow quite fast, right? So corals like staghorn corals, your kind of classic branching corals, these are corals that are growing up on the top of the reef where there's lots of waves. These are the corals that are protecting, that are absorbing wave energy, but they can grow really fast. Each branch can grow, maybe a foot a year. But, it's important to remember that for every, you're taking 5 steps forward, but you're also taking 4 steps back, because you have all of these other geological processes that are taking place, like erosion, and you've got parrotfish and you've got sea urchins that are bio-eroding and eating away at the base of the reef. So, you're constantly trying to grow up while, there are other things that are kind of eroding you and keeping you from growing up, or perhaps undermining you and collapsing. And so there's a lot of chaos in the system. There's the corals themselves kind of grow in this very tessellated, ordered, geometric fashion, but you throw it into this chaotic world of the environment, and you wind up with really unique things that are taking place, and it results in a lot of evolution taking place as well. And one of the things I always like to shout out is, Charles Darwin was the first scientist to write a book on coral reefs. Before his theory of evolution came about, he was focused on how do coral reefs form, and he came up with this hypothesis that coral atolls formed around volcanoes in the middle of the Pacific Ocean. That's where he was sort of studying them. And he realized that over time, after the volcano went extinct, the volcano would subside, but any corals that had started growing around the edge of this volcanic island would continue to build up as the volcano subsided. And that's why you wind up with these lagoons and atolls in the middle of the Pacific Ocean. And it's hard not to understate how important of a revelation this is for him to understand the time scales that we're dealing with. And that's something that coral, I think, does a very good job of reminding humans of this idea of time and space and where we are, because corals are really growing on kind of a much slower timeline than sort of, our perspective is all framed around a human perspective of time and, 75 years or so on Earth. Whereas, corals are living at this much slower time scale. And so for Charles Darwin to recognize the slow rate of growth of coral, and the slow geological processes of, subsidence and, and mountains forming because of geological processes, he realized that the Earth had to be millions and millions of years old. So this is really the first time that anyone starts to begin to understand the time and space in which we're living in. And it really comes from looking at coral, that then, in my opinion, he is able to really understand that, wait, these processes of evolution in the context of being millions and millions of years of time suddenly can take place. So that's, something that I always try to mention, that, Darwin is really kind of the guy that blew everything open and ushered in modern science, this idea of a hypothesis. Nobody knew that the Earth was filled with, magma, and didn't realize that there was plate tectonics. This was completely unknown just 160, 70 years ago. It's not that long ago. And that's another thing that's also really important to remember as well is, hold on here. Let me see. Lost my train of thought. So I think I'll go directly to kind of where coral reefs are found. So, one of these fundamental problems that corals have is they're cemented in place, right? Adapt or die. There's no picking up and swimming because you don't like the water conditions, or you bought up, your real estate and you're upset with the view, or something's blocking your view. You have to deal with it. And so corals are pretty amazing. And as a, it all comes down to turf warfare with a coral. Real estate, you're protecting your real estate. And so, even though corals form these very diverse habitats where there's just a tremendous amount of different species all living together, when it really comes down to it, they're still protecting their own boundaries. And so corals, being related to jellyfish, they've got tentacles, they use them, and they sting each other. And they do this to, protect their own real estate, to encroach and grow over their neighbors. But they can also do other things as well. They can produce chemicals that are, say, growth inhibitors, which are something that scientists also are very interested in, say, for cancer research and pharmaceuticals. But they also do physical things, like if they can grow up and if you can shade your neighbor, and take their sunlight, then you can also sort of outcompete your neighbors. So, this is not really all that different than a lot of the same motivations that people have when they're building or trying to have the best view of their neighborhood. But being stuck in one place, of course, has a lot of other problems, like how do you mate with each other? So, corals, they asexually reproduce, like I mentioned. Of course, like when there's a hurricane and these corals get broken up from the waves and the surge, every little piece of coral is able to regenerate into a whole new colony. So it's quite similar to the way you can take a cutting of a plant, and root it and then, start another clone. I mean, all of the fruits that we eat, the Hass avocados, every Hass avocado you've ever eaten is a clone that all came from the original Hass tree. So this is something that, is relatively common in the plant world. But, if you want evolution to take place, you need to have the chaos of sex to make that happen. And corals really do this probably better than just about any other organisms on the planet. And so probably one of the most amazing facts about corals is that, in my mind, not only are they the first city builders and real estate developers and architects of the planet, but they're also the first astronomers, and they are really the first timekeepers of planet Earth. So the way that corals reproduce is that they're all synchronized to release eggs and sperm into the water at pretty much the exact same time. And so how do they do that? Because this only takes place a couple of nights out of the year, and it's because, being cemented in place, they're little astronomical observatories. The earliest astronomers on Earth would have realized that in order to kind of keep a map of what's happening in the cosmos, you had to do your measurements from the same exact place. So this is why you have places like the pyramids and Stonehenge and all of these ancient places that were really built to observe the movement of the cosmos itself. And corals, even though they don't have eyes, they don't have a brain, they are sensitive to light, and the full moon is a very powerful thing. And so they basically spend their entire year, their entire sex life is dependent upon showing up at the party at the right time. So this is all that they really have to think about all year long. So you can imagine that it's a pretty high priority. And this is, over millions of years, they've got it down and developed a really good sense of time. And so they're literally tracking the phases of the moon. So, and they're also tracking the angle of the sun, the length, the day length, and then of course the seasonal changes in temperature. So, it gets warmer in the summertime, longer days. So here in South Florida, typically it's several nights after an August or September full moon. All the corals on the reef release their eggs and sperm in the water at the same time. And this means that, a single coral colony can reproduce with multiple members of its same species all at the same time. And also opens up the possibility of even hybridization with closely related species. And these are all things that greatly accelerate the evolutionary process. So like you think about an organism like a rhinoceros, these very large mammals that reproduce very infrequently, they don't produce that many. There's a lot of effort into having to raise them. Evolution is going to take a long time to develop when you're dealing with those types of time scales. But with a coral and the way that they reproduce, in my mind, evolution is something that can happen a lot faster, and it's something that I think that we're seeing here in Miami, for instance, with the Coral City camera and these corals that are moving in and around Miami and sort of taking advantage of our human infrastructure, where we've taken cement and we've used it. Our intent from a human perspective is to fortify our land so that it doesn't get eroded back into the sea. And that's our primary, reason for spending all this money to develop seawalls and riprap that is protecting the shoreline. The marine life just so happens to find it quite useful. And so, because these corals are sort of, they float in as babies, as larvae, and they settle out. And the ones that are surviving here clearly are quite resilient. And so it's almost like Miami itself is like a living laboratory for coral evolution to take place. And you couldn't build a laboratory like this. It would take billions of dollars, and you'd still be 10 years behind, because everything that's happening is sort of happening on a natural level, and it's been happening for decades here in Miami. So it creates a really interesting opportunity of these intersections of the coral reef environment, as well as the human environment. And I think that this is really kind of it's in a way, it's the future, where humanity continues to encroach into nature, and nature continues to adapt, evolve, and is forced to live around human development. And so, what we're seeing is a form of evolution taking place. And one of the sort of more exciting discoveries that I've made in the sort of marine environment here in Miami is that there are these hybrid corals of 2 endangered species that are living inside the shipping channel in government cut. And this is, a hybrid that is very rare. I've never seen out in the wild. And they appear to be more resilient than either of their parents, which is something that you hear or you think about, like when you adopt a dog. If you get a mixed breed dog, they're often healthier because they're not so inbred with all kinds of birth defects and things. So having hybridity and having a mixture of genetics from different parents, et cetera, is a really healthy way to kind of create very hardy and rigorous offspring, which is, again, something that it appears we're seeing right here in Miami. So of course, there are a lot of problems with corals and coral reefs right now. I've touched on some of those, like global warming is a major one, but there are other human problems as well, like just the pollution, runoff, sedimentation. They need clear water. If there's fertilizers in the water that create algae that is out competing with the coral, or overfishing, because we're especially in the Caribbean where people eat parrotfish. Parrotfish are an important herbivore on the reef. They eat the algae that outcompete with coral. So if you remove the parrotfish, then suddenly the corals have a hard time surviving. And so coral reefs and corals are really being hit on all fronts by lots of different problems. But really the elephant in the room is this man-made climate change that has come from this excess of fossil fuel we put into the atmosphere. And when you think about it, all of that fossil fuel is just old solar energy, right? It's simply algae that died millions and millions of years ago and sort of settled to the seafloor, and then got buried and buried and buried. And then, under pressure at the bottom, underneath the ocean, it turns into oil. And then we just sort of are tapping into all of this all of this extra energy. And, anytime you create energy in a system, most of that energy is released as heat. There's a lot of inefficiency, and we're just, in order to fuel our industrial ambitions and our technological ambitions, there are consequences for that we are now realizing, and we're seeing that impact these natural environments, and corals in particular. So now, of course, especially in South Florida, coral disease has become a big problem, because even our microbiomes have impact on each other. There are diseases. There's a coral disease that affects elkhorn corals that comes from human sewage. And this is like the first time anyone has identified a pathogen that can be passed between a vertebrate and an invertebrate, which is remarkable. And that's really maybe how I'll kind of wrap up the coral educational component. Is the other thing about coral that is really important to keep in mind is that it's not just a symbiotic, a colony that is animal with an algae that is providing it with this photosynthetic energy that allows it to grow these great colonies. But the entire coral itself is a community of microbes. There's bacteria, there's fungus, there's viruses, and they're sort of acting like a probiotic immune system. The coral doesn't have white blood cells. It doesn't have the same sort of systemic immune system that a human does. So it utilizes, this natural balance of microbes that kind of act like an immune system. And, in recent decades, with influx of other microbes and nutrients into the system, have really seemed to have kind of thrown everything off. And we're beginning to see a lot of coral disease where we didn't previously have disease. But it's a reminder that, it was the scientists studying the corals that recognized that, wait a minute, a coral is not just an individual. It's a whole community of life unto itself. And they gave that name, they call it a holobiont. And of course, you look at a coral under the microscope and you see a whole range of life forms. And then the scientists turn the microscope around on ourselves and we realize, well, wait a minute, we're covered in microbes too. And now we know, over the past 20, 25 years since scientists realized, what a holobiont was, we realized that so much of our outlook and our health is also dependent upon having a microbial community that is healthy. So now, last century, everyone was into antibiotics for everything. And we realized at a certain point that, wait a minute, you can't just wipe out all of your bacteria. That's not good. And ultimately it causes the bacteria to create even more pathogenic forms. Whereas now, everyone talks about probiotics and yogurt, and this is, again, comes from our understanding of coral and how, really there's this sort of microscopic world that connects us, at the microscopic level. And coral itself is this organism, and, in my mind, it sort of bridges this whole spectrum from the microscopic level of this microcosmos all the way to the telescopic level, to the actual cosmos of the sun and the moon. And really when you begin to sort of respect and understand these corals in that way, you realize, well, they have a tremendous amount of innate knowledge contained within them. And for instance, just as corals are timekeepers, in the sense that they are synchronized and they know essentially what time it is because they have to mate at a certain time of year, but they're also time capsules. And that's also something that scientists have been able to utilize to great benefit of our understanding of our planet. So for instance, you can just the same way you can take the rings of a tree, and you can count the rings and you can figure out how old that tree is, but you can also learn things like, oh, there was a forest fire in this year, or there was a really cold winter. You can do the same thing with a coral, because they leave a limestone skeleton, which means that they actually leave a much longer record. So you can go back and look at a coral that's 100 million years old and put it in an X-ray, take a slice of it, put it in an X-ray, and also you can look at the chemical composition of their skeleton, and you can look at things like isotopes and things that tell you, oh, there was a volcanic eruption, or there was all these things that we can utilize to understand our past world. And one of the things that's really remarkable is that we know that, say, I think about 250 million years ago, there were 420 days in a year. And that's because the moon was a lot closer to Earth, so Earth was spinning on its axis a lot faster. So, it was still the same, the year was still the same length, but we had more days and night. So, there were less hours in a day. And it's, we know that the moon has slowly been pulling away from the Earth. And because, the moon is what controls the tides. So, the fact that we have one moon around our Earth is remarkable and miraculous, because if we didn't have a moon at all, there would be no weather, there would be no waves on the ocean, we would have no tides. That chaos wouldn't be here to help speed up evolution. If we had two moons going around our Earth, we would probably have too much chaos. And the waves and the oceans would probably be far too dangerous for much to live. And so, having one moon is really amazing, something we shouldn't take for granted, because it does have such a powerful impact on all life on Earth, like at a physiological level. So something, we are kind of the clock, like we spin around our axis every 24 hours. The moon rotates around the Earth every 29.5 days. So there's our month. And then the Earth rotates around the sun every 365 days. And that's our year. So we are physically on the clock. The corals are tuned on that clock. And so, by sort of recognizing the cosmic nature that everything's interconnected, by learning from the coral, that really is kind of this larger goal, I think, that Coral Morphologic has, where, if you look at it only specifically from a very scientific perspective, sometimes it's easy to lose that big picture, particularly, when you're a scientist, you're really trying to focus on a very narrow problem. And it's important, I think that what Coral Morphologic tries to do is try and put it in human terms, these things that are very scientific in nature, that then become relatable. And when things become relatable, then we can have empathy for them, because again, these are organisms that don't have that don't have brains, they don't have eyes. You think about a panda is this cute and cuddly icon of conservation. It's very easy to get behind that. But a coral, how do you fall in love with a coral? But I think, it is this, their almost alien cosmic nature is really what draws you in, and the colors that they have, which I guess I didn't really touch on, and I should have. They are fluorescent, and it's still a mystery as to what the fluorescence is doing for the coral. It appears that it's related to like a form of sunscreen, so again, these colors, they don't have eyes. That's not because they're trying to attract mates, but for humans, we have been attracted to them. And I think that it has made, my job as a communicator of this science a lot easier, because again, people are willing to pay attention more because of the colors being so bright and colorful. And then if you can capture someone at that aesthetic level, then they're sticking around to pick up kind of more these deeper metaphors that and sort of education that a coral then allows. So everything that we do is kind of trying to get people to understand this relationship, and in particular here in Miami. We're a city that at one time was underwater. It's been underwater multiple times. And, and in the future, that's something that we have to be mindful again of potentially happening with sea level rise from global warming. And so the idea that the planet is static and unchanging, looking at corals and coral reefs, like, we know that things are constantly changing, and you constantly have to adapt and constantly have to be resilient and come up with ways to to protect yourself. And that's, ultimately corals are amazing multitaskers, and we have so much to learn from them that I think that, we can learn to live as better, humans and species on the planet, since ultimately, like, we're all living in the same fishbowl. Every bit of pollution that is released into the air and into the water, it doesn't matter. There's no boundaries on that. We're all in this. You think about whales. Whales swim around the entire planet. We're living in their aquarium, and so there is no separation between the natural and the unnatural when we're all in the same sort of experimental jar. So I think on that note, I'm going to kind of just wrap it up so that we can move kind of into more specific questions that you might have, and Eric can do some presentation. And yeah.
Thanks, Colin. Just one thing before we go and move to, do you want to say a few words about your art project, the kind of what you've been doing to kind of draw attention to?
Yeah, I'll show some real, I think ones that are very specific to this idea of corals in space and time, and in Miami in particular. So this here is 2317. This is the FIU Forum on Miami Beach, a Rem Koolhaas designed building. And one of the things that an artistic output that we've always really liked is projecting coral onto concrete, because it references the geologic past of Miami being underwater. It references the technological present, and it sort of brings up the idea of a future that makes you think about, hey, this could be the future of Miami if we don't do anything about it. So this is, we've done a number of different projection projects around the city. We really try to kind of overlap technology and the latest kind of the latest technology with being able to present in a way. I mean, there's so much that Coral Morphologic couldn't have done were it not for surfing this wave of consumer technology that became something that anyone could do. It's easy to take for granted, just HD video, GoPros, all of these things. If we had started 10 years earlier, I don't think would have been possible. So there's definitely a technological element, and also overlapping with pop culture. So, if you got the time, we did a collaborative audiovisual album with a band called Animal Collective. You can watch Tangerine Reef. It's a very psychedelic, trippy audiovisual journey of lots of coral color that you can check out. We're constantly trying to do things, involving new technology. And really, I think, there's a therapeutic effect that comes from appreciating and enjoying these underwater worlds. And that's what really, I think, our most recent art project, the Coral City Camera, we hear from people every day about how this has improved their lives during the pandemic. They've been stuck inside. A lot of these people are, from places that are much colder than Miami. And just to watch colorful fish swimming around has not only provided them with a sense of calm and lowers their anxiety, but it's also brought people together, so it's like a digital campfire where you've got all these people kind of gathering around this beautiful community of marine life, and they're connecting with each other on a human level and getting a sense of connection that obviously is important and healthy, and has perhaps been lacking this past pandemic year. So technology, pop culture, fashion. We've got a collection of clothes coming out with a surf and skateboard company, Volcom, in March. That sort of brings these. I see coral, the photography, as sort of 21st century animal print. Things like leopard print, cat prints are never really gone out of style, especially in Miami. But coral presents this whole new world of animal print that I think, opens up a lot of doors into fashion and because it's a natural fluorescence. I think a lot of people tend to think of Miami as being a very artificial, plastic, vapid kind of place. And the history of coral here is that corals were the original neon icons, the original city builders, and there's nothing artificial or cheap about them. They're the real deal. So we see an opportunity for Miami to kind of reclaim this this bright, colorful existence as being something that isn't plastic, that's actually literally in the bedrock of the city. And that's something that we want people to develop a sense of pride in this city. We're the only city that's bordered by 2 national parks, and I think that the coral environment, the coral reef environment, is something that not many cities have manatees. Not many cities have megafauna. There's so many things that we can build off of that really make Miami such a great place to live, if you know where to go and what to appreciate, which I think is, it's important not just for our local community, but then, the global community to recognize that, wow, Miami's got some really special things happening that aren't just, nightclubs and, the beach. See, but I definitely recommend everybody check out the Coral City camera. We're at deep low tide right now. I'm going to be in the water at about 3 at high tide. It should be really quite nice at that time. Sort of a whole, just keeping the camera running itself is it's almost like a living organism that gets I have to stay on top of it all the time, 24/7. So I apologize. I'm going to redo my reset my connection here. But yeah, are there any other questions?
Yeah, Colin, maybe we can while we're having a discussion at the end, we can see some more of the coral, because it's absolutely spectacular.
Sure.
I've got to say.
Yeah.
Maybe we should just move on briefly to, we got Eric and Philippe showing some of their coral reef 3D printed work. So
yeah,
maybe it'll come back in a second and
yeah.
later on. But so do you want to just unshare your screen, and I can invite
yeah.
Eric to
stop share.
Yeah, so I'd like to call upon Eric now. Eric has been collaborating with Colin over the years and is still collaborating with Colin to show some of his collaborative work and that he's been doing with you. So welcome, Eric. You need to unmute yourself.
Just taking off my Volcom hat to say chapeau to Coral Morphologic. I mean, we've been working with Colin for about, I'd say maybe 5 years through these FIU Master's Project Graduate Studios. And I would say that perhaps we're working under the influence of Coral Morphologic this whole time, because taking in is really like being under the influence of a powerful drug, which I'm sure they are naturally. So thank you for that great presentation, and thank you for all these years. I think that one of the things that I probably should start sharing what I have here, because my time is short apparently. One of the things that really attracted me to work with Colin, which, by the way, I got to know the work of Colin Ford and Coral Morphologic through Neil Leach. When he first arrived, he alerted me to it, and damn it, I did not know about it. Is this idea of the xeno, the otherness, that kind of aspiration, knowledge of the otherness, which is, in architecture for my generation, maybe started when connecting to using new software that will allow you to explore that otherness in terms of formal explorations. But and I'll show you some of the work that just simply some applications of of this notion of being under the influence of choral morphologic through the work of my students first, and also through other ways in which Colin and I are collaborating now. And this idea of kind of this orientation that one gets to experience underwater, everything that's a reference to how we exist or how we think as architects in this earth is completely challenged underwater, especially this the notion of disorientation, or the kind of the reef that you can have underwater is very different than the kind of the reef through the city that you can have, even if you wear Constant or if you wear any of the other guys. The situation is international, who are able to reconcile and map out this notion of the city through psychological and sensations, perceptions. I guess when underwater, a lot of it is just simply gone. All the rules that we consider for architecture, grids and things like these are completely irrelevant. So that's one of the things that attracted me the most to working with Colin. The other one being coral in terms of the microscopic to the macroscopic in this sort of like cosmic time. So my interest is on time, really. And given that I have a short time, I'll show you some of these things. I guess I should enhance my screen. Are you seeing the big full screen?
Yeah, but you haven't got the PowerPoint on full screen yet.
Oh, then you're seeing my screen. Let me see if I can.
Just click on the icon at the bottom left. Right. There we go. Great.
I did, but it's just how the screen is swapped to mine. Let's see if I can do it here.
I know those guys.
Yeah, at least one of those, right? You're still not.
Mm-hmm.
You are. And there you go. Be okay, right? Guess
we can't see your PowerPoint. We can't see your PowerPoint, Eric. Hello, Eric?
Here, no worries. I'm just trying to figure out. Because I had two screens connected and was not showing the proper one. Does that work now?
No.
No.
No. Are you seeing my PowerPoint?
No.
Nope.
No, you're not.
The way you had it originally was fine.
Yes, unshare it again and try sharing again.
I'm doing that. Let me know when you see it.
What?
Is it
Can't
there?
see it. No, no. Maybe go back to the way you had it before. We could see it then.
I did. I just did. It's having two screens is getting on the way of it. Let's see if I can. Give me 1 second. I should be able to solve this. It's only eating away my time, Neil. Don't worry about it. I'm just opening it again. It should work. Let's see. Let me know when you see it.
Can't see it yet.
No, it says that you've started screen sharing, but it's just a black screen. So I would just try and do what you had when we could
I
see.
did.
Okay.
Maybe now?
We can see you.
No.
Let's try again. No?
No.
Anything but.
I'm not sure what happened.
Um,
I'm wondering if we should get Philippe to present his stuff
Yeah.
and then come back
Let's
when
do
she's
that.
sorted it
Let
out.
me
Eric,
just start.
Yeah.
Stop everything, start it over while you can do that. No problem. I don't want to.
Is that okay?
Yeah.
Philippe, are you good with that?
Sorry about that.
Hi. Yeah. Philippe, do you want to start your presentation? Is that?
I'll also leave and reconnect. That's can.
Yeah, but maybe I can do it after Eric, or it's yeah.
He's just having problems
Let's try
connecting to his PowerPoint.
Oh.
I don't know why.
I'm happy to take questions now too, if there were any.
Oh, okay, yeah, that's a good idea. That's a good idea. Yeah, Colin, one thing I wanted to ask you was, I mean, you presented the corals as silly city builders and so on. And one of the discussions we've been having recently was about, whether these any other entity has a form of consciousness, as though they can think and so on. To what extent do you think corals are self-aware? Because you spoke about them as though they were kind of fighting each other. It was very interesting, beautifully interesting. But I mean, are we anthropomorphizing? Are we sort of trying to project humans' values onto them, or to what extent can they think?
Well, I mean, I think that defending your territory is absolutely not a human. I mean, that's an animalistic thing. Plenty of animals are interested in defending their territories, and that obviously you don't need to. It's really, everything can be broken down to a biochemical basis, and oftentimes, in particular where corals are defending each other, sometimes they start growing towards each other, and then sort of it escalates over time, where initially, they're not really killing each other, but each one, it sort of like becomes an arms race to develop stronger and stronger tentacles. And so, these are just things that, are just reactions. I think, I definitely don't mean to be. Our goal is, I would say, the opposite of anthropomorphizing coral. We're trying to coralize humans, right? So but obviously there's a bit of a handshake there, where it's the center of the lemniscate, where where the middle of the figure eight, where all kind of connects back up again, I think.
Okay, so we've got Eric. We can now see your screen.
Yeah, you can. Awesome.
Don't do anything to lose it.
No.
Okay, far away. Okay,
well, you need to put so let's try it this way.
Put the PowerPoint on full screen, maybe.
Let's try.
Okay.
Can you see it in full screen now?
You want to click on that little icon on the bottom, which has got the screen, just to go and.
I did.
Oh yeah, now we can. Great. Okay, good. Thanks.
Okay.
We skipped out again.
Yeah, it's just that there's a lag. So give it a little while. I'm gonna put it again. So that seems that works. Give it a little bit of 10 seconds, and it'll probably pop in. Let me know when it's ready, and I get started. But yeah, I've.
We can't hear you, Eric.
Can't hear me. Damn. Can you hear me?
We can, but it's not a very good signal.
Okay.
Yeah.
All right, let me see if it's just that where I am moved is not the best of connection now here at Embus, but let's try it. Can you hear me well now? So then we can go ahead.
Yeah. Yes. Yeah. Yeah.
Okay, very good. So let's get it on. This is you know, of course there are the tremendous crisis that's affecting not only will affect and will suck its own crisis as we breathe what it generates. These guys, you know them well, and as of late, this really cool project that Morphologic has of the Coral City camera has been quite an interesting opportunity for us to begin to think also on, compared to the first series of studies that we've done with in this collaboration, to begin to focus more on real deployable units that we do want to see being caught by a camera like this. So we've done a series of projects. So I'll just show you a synthesis of a few projects. This is a project by Paula Castel. This is one of the areas that has been of interest to Colin, which is, he's been kind of for us like a curator of certain areas of Miami, coastal areas in Miami that have been of interest to him, especially because of how he was telling about the discovery of this very resilient, very strange kind of urban coral that they discovered grows in areas that will be otherwise thought of be very difficult for it to thrive. And this is a project that it's really taking on the entirety of the South Point Park, which is of interest now to us because at South Point Park and extending north, there's a new project and relatively new initiative by its artistic director, working with OMA, with Rem Koolhaas's office, and we're collaborating with them as well. But in this particular project, it was all about the exploration of kind of trying to augment all the possible edge condition and all its, and augmenting, also intensifying its for coral to be able to take advantage of the very special condition that it's situated on government's cut. Well, it's an artificial tray so that the ship, big ships can come in to the ports, and it creates all these very special, very active currents and a series of other conditions that coral can thrive on. And then this project was trying to really internalize that into a park and re-envision this park, which otherwise is a very popular one, and bringing in a series of layers, coastal layers that would augment the potential for the kind of biodiversity that we want to see thrive in the corals. It's not just about corals, but all the other ecological levels that coral brings into it, and it has an influence because of that. I'll just quickly run through these images like a show and tell, like you would do with your kids in kindergarten. And this is another project that we did by Alejandro Diaz in the Brickell Key Island, where the South River connects out into the bay. This is not in South Beach, but really exploring some of the conditions of the bay where the situation has become super critical as of late. But we're in this project, it's kind of visionary, kind of trying to see ways in which contamination, the contamination of the water, pollution in the air, could be transformed by sort of machine-like tower that is not another office tower, but it's kind of hacking onto the skyline of Miami Beach. It's of downtown, and taking on its characteristics, but also taking on a kind of characteristics of coral and housing a mechanism, sort of like a refinery that would transform the polluted air through photosynthesis and algae, incorporate into the mechanism and sort of outpour into a new sort of curated area for coral reef to grow with new kind of better kind of water, sort of trying to transform the negative into a positive in a sort of naive way, but really interesting way to think of architecture as being some sort of mediator, some sort of infrastructural device, not just, another office tower that we don't need anymore of. So this is just shots of that. And then the latest, moving closer in time, the last couple of years, the studios have been much more focused, like I was saying, in really beginning to develop coral units, especially on the first part, where we do the seminar and trying to understanding characteristics of coral, in particular the coral that is here, and trying to see what can be teased out with the knowledge that we also gather from Colin and other things. How can we begin to generate the substratum that would allow coral to grow? So this is a really funny thing to do also, because you're creating something, a kind of architecture whose post-occupation will be just becoming very furry, right? And it's very difficult even to envision with certain digital techniques how that would be. So this one is presented completely white and pristine, but knowing that the kind of articulation of these coral reef systematic repeatable units that produce variation how can they also accommodate for all that other furriness that it will have, which we're not seeing here, but we're seeing its intricate constitution. So this is then, there's a funny moment where after studying coral and modular units that are repeatable, that they can accrue and aggregate into larger reef tracts. Then there's that moment of interpretation. The students have to really think about this funny issue for architects, which is scale and size and relative relations between the two. And especially underwater, all of that is very relative as one begins to think about time as the real commodity, right? Especially in this era, but for many other cultural reasons. But in particular, with the effect of time, will render all these elements, which are pristine and architecturally defined, into something.
Eric, do you want to try switch? Sorry, Eric, do you want to try switching off your own video camera? It might improve the bandwidth. Might improve the connection.
The bandwidth is what I have now here. So
just switch up your video off, and you get more better connection, I think.
Oh, okay. Can I do that? Let me look into that.
Yeah. We could
let me. Does that work?
There you go. There you go.
You're still seeing it, but you're not seeing me, and that's better.
Yeah, better connection.
Let's hope it's that. Very good. So,
thank you.
The students have to go through this kind of leap of faith and also exercise of taking the scale of these there's known quantity size coral units that they developed, and try to think ways in which that can become an architecture. And this is one of the versions of that, where then we're deciding the student takes on MacArthur Causeway, which is this link between the bay and South Beach, which has parallel to it the artificial island of the port, and a series of artificial islands that in plan look like pills or something that are connecting to MacArthur Causeway. So it's an important artery. And through Colin discoveries, he communicated to us that there are a lot of really interesting moments along the riprap edge conditions of it, where coral is thriving. A new kind of coral that is more robust can exist there. So we're trying to take advantage of that particular strange condition and working on the side where that is not compromised by the big ships. And in this student is developing a whole sort of like urban park that will be able to generate, through the articulation of certain elements, to generate power to the city via osmosis and salt ion exchanges. So develops a whole mechanism for that. But and then it's about how this element, this new piece of architecture, is kind of like a building. It's a discrete piece of architecture, is everything but, and it's mostly just a part of a much larger system that is there to kind of produce a type of sublimation of the negative issues of the ecology into something better. That's always trying to be the aim in this kind of
studios. And then you see how this is beginning to articulate a series of new internalized landscapes and experiences for visitors, where this is a sort of combination of gallery, museum, as well as an institute for coral research. And there's, you know, like I said, this is the kind of opportunity that we have, understanding the being underwater and being in a different medium where the body floats and exists differently, is that everything we knew about the possibility for architecture can be different and can, you know, it's liberating in many ways, and it kind of justifies the kind of obsessions we have about forms otherwise. Anyways, some more shots of this project, which then, you know, it's interesting how it begins to internalize. You can be somehow, what happens is, what this student was able to obtain is the experience that a small organism or a fish would have, now a human can have it, while at the same time housing those coral nurseries that project is to have, and a series of devices that would ultimately enhance the kind of energetic production. And another version of this project from last year, getting closer in time, focusing much more also on some possibilities with technologies. This obsession that Renzo Lopez, the student, had on understanding how we understand, how we used to exist in nature, how we exist now, and how we could exist through the aid of new devices. This is one device that he came up with, created this machine, this crazy robot that, you know, he understood and interpreted with that coral is none other but a printhead that's just operating on its own constantly over the years, depositing layers of layer through thousands of years, right? So why not then create a device that can augment this performance in a directed way, in a curated way, in an organized way. So he not only came up with these other robots, a robot that will be able to a sensor type robot that would the conditions to destroy certain parts of the architecture to allow for the new architecture to plug in. And then they went about developing how would this operate and developing a whole system that would then generate in 3D print in this modality. 3D print in a way that this will be guided, the sensor robot would guide what this new 3D printer needs to generate in terms of coral substratum, coral reef, right? So there's an interesting kind of interactivity with the actual ecology there and the shifting conditions that we always have here in Miami. And then he decided to operate really, try to look for what are obsolete infrastructures, given that a lot of our existence will become obsolete with the sea level rise. He identified bridges and studied different possible bridges and what would that sensor robot will be detecting, and how in these several different points, how can this new constructor in a way be able to operate to generate new reef. Ultimately decided upon the moment where MacArthur Causeway arrives into South Beach, just continue with this obsession with MacArthur Causeway. And this happened at a time where COVID first hit us. So everybody was craving to go out and walk. So he decided it's going to replace the shortest point between A to B, which is this bridge, and consider it obsolete, because over time it will also become obsolete, and generate the longest possible path to go from A to B. A completely extravagant, excessive infrastructure for walking or for biking, not for cars. Cars will be gone from this vision of Miami in a few years from now. And then this coral begins to get self-generated. It's kind of creating a sort of autopoietic condition, and begins to study what kinds of spaces will those be for humans, besides I guess this guy focused much more ultimately on the kind of post-occupation, post-drama, what kind of new life will happen, what kind of new layer will begin to operate on top of the infrastructural ecological purpose, new coral reef substratum. And so just a collection of, also these are some of my students I'm coordinator of the Design 8 studio, middle of the road, where students are to work on a really crazy, strange alleyway that we have around 15 blocks, half a block away parallel to Ocean Drive, where you can really see there the underbelly of all Miami tourism and the kind of face that Miami puts to the world. On Ocean Drive, where you have all these glitzy, whatever, funky, trashy hotels and bars and clubs. But half a block away, you have an alleyway where students do projects there. So this guy was kind of almost taking that underbelly of Miami out here to replace a bridge. And more on that kind of architecture, what is ultimately the impact over the years. Was able to get gorgeous drawings out of speculations, right? I just move fast and skim through it. And this is the end of the seminar that we just did. Leading now, we began the second part towards the generation of new architectures. But now we're working specifically with a group that, Colin, I believe you have not shown much of it yet, but it's really interesting because we have a really visionary legacy type project now in Miami called the Reef Line, which has been generated by a foundation led by Jimena Caminos, as they linked formerly to the FIU hotelier, former husband of hers, and also with Colin, who's been a big activist and promoter of these ideas, and which we as a studio have always been in this kind of elastic relation with Colin, exploring. And now we are officially working with the Reef Line, with Jimena, with the whole team, with Colin, and with OMA. OMA has done not only that FAINA Forum project, but also now has produced a master plan. I'll show a couple of images of that. But now, so it is at this moment in particular that we're joining that group, and we're working on that project and working towards the Venice exhibition as well with them. So this is just the end of last semester, where they're just doing a seminar exploring the aggregation logic of these units. The students were looking at bioerosion in particular, which is a fascinating thing. You find coral detritus, and you also see how certain worms or certain species have cut tunnels into it and have produced really interesting model. Even fish, the way they eat away at coral, they produce a really interesting series of traces which index time in a funny way. So we gave the students at the western edge of South Point Park an inlet that exists to explore and to drop there some of their modules and see in what way can we interface humans and all the life that thrives underwater. And this is one of the ways. And I think this is an image that I really like, in that I think it encapsulates some of Colin's vision that ultimately coral was here 1,000,000 years ago, 1,000 years ago, and it should come back. It should begin to do its own thing. We can guide it or help it or see it work. Moving along, this is the Reef Line project that I mentioned. I'll just show very few images of it. It's a project led by Jimena Caminos and the Blue Lab Initiative project. In partnership, I guess, Colin and Morphologic are very active in this project as well, and they were nice enough to work with us and incorporate us as well. This is in this project. This is South Beach. This is South Point Park. Somewhere here begins that alleyway that I was talking about, behind here. So there's an existent series of reef experiments there. And now this is plugging in, trying to extend that logic and beginning to set up a series of stages of development of underwater art galleries as if it were, but also which will naturally generate a lot of new substratum for coral to grow on, and will be commissioned artwork to artists. And OMA did the master plan. This extends further north, like 100 blocks until Howlover River. And then this is one of those pavilions commissioned to artists. In this case, will be one designed by OMA. And this is a system that they developed to produce a barrier that would protect all of these pavilions, and it also served as a diving route to connect in between the the units. This is a little bit of that. This is a project by Leandro Ehrlich, which he did actually that project of cars, but on the sand. Now the cars will be underwater as one of the commissioned artists. A lot of the work that we've been doing with the students, here's, I articulate this part towards a different kind of work. It will be the work of Monad Studio, but also my role as curator, in which I am also collaborating with Colin and with Neil and with his partner Banaz and a lot of other people. But I've been invited to partake on an academic series of presentations at Venice, where schools from around the world like RMIT, Bartlett, and others, and ourselves will be showing like another final review, but in Venice with really cool reviewers. So we're glad to be a part of that program. This is still me as professor of my students. As curator, I'll be curating two exhibitions in Venice. One entitled Feedback, which is really about time. In other ways, where it's a lot of people that work, including Coral Morphologic, because their work is totally about time. And this is amazing group of people. I'm not going to spend time on that today, talking about that. But one of the projects that I'm doing for another part, this is in the Italian pavilion, where I'll be curating these two shows. And I'm a creator of a sessione, or a section that deals with these subaquatic projects. And the reef line will be included there. Some work by Colin Ford and Coral Morphologic will be included there. And then an installation that we're building here in Miami, but projecting it there, will also be there. This is a gallery that MBAS, where I'm now, the MBAS, where hopefully you guys come and join us and see all of this work and work here at a point when it's possible. And we are beginning to envision this sort of structure, like a Noah's Ark, that will have not only coral reef related elements and the kind of elements that thrive usually when coral is alive. It's like a piece that is able to also have some vitrines and cocoons that will display some of the actual real coral stuff, dead and alive, and in between states. This is how it's beginning to evolve. Some of these are cocoons that display little objects inside from the real objects from the reef. Organisms. Some of them will be screens for Coral Morphologic to show some of their amazing footage. And some of other are flat layered acrylics that will hold. This is a previous experience where some of that was developed. This is a collaboration with Alessandro Melis, who's the curator of the Italian pavilion. This is something we had done that also had these biomes. And just to show you what those strange ovoidal acrylic pieces hold, which is these, which you're probably familiar through the work of Ecologic Studio, Claudia Pasquero, Marco Poletto. This is a self-generating pattern that has mode moving across and producing traces of its moving, trying to seek food. And some of that will be incorporated. So there's some living organisms, there are dead stuff, there is footage of things living underwater. All of these contained in this structure. And these are some things that are beginning to be tested in this humongous printer.
Let's give it a while, because people have got to go back on. I'm not quite sure. Could I ask Jinan and Jiki if the live stream is back going again?
I'm really
Okay, I'm waiting for the students.
Okay. I think we should move on to Philippe now, just to kind of be running out of time. I'm sorry about that. I don't know what happened.
Yes, it's okay.
Yeah. Okay. So let me just go. Let me just okay, so the YouTube's back on live. So yeah, Philippe, let's move on to your thing. I don't know what happened there, but we yeah.
I can't share my screen for the moment, so I need the host to authorize me to share the screen.
Okay. I'm not the host. Who is the host here? G, are you the host? Okay, Philippe, yeah, you're now co-host. Yeah, you should be okay.
Okay, good. Thanks a lot. Okay, so do you see my screen? Yes?
Yeah.
Yeah? Okay, perfect. So I'm gonna show very quickly a couple of examples of coral reefs. As some of you know already, I'm an architect. I'm a visiting professor at UCL Bartlett and also associate professor in Paris. But most of all, I initiated and funded, especially as a founding CEO, a large-scale 3D printing company whose name is X3 at the very end of 2015. And recently, this company has produced a couple of artificial reefs. So since this is the topic of today, and I was invited to speak, I'm going to show a couple of examples of that. So as it was being said before, the problem at the moment with coral reef is that sometimes they are completely bleached. I mean, some of them disappear, but some of them are also bleached, which means that it's a failed ecosystem, which creates a lot of problems for fishes and all the animal and vegetal, I mean, plant populations in this ecosystem. What matters with the reef, it seems, is that ultimately one of the rules is the importance of the specific surface. There's a very large need of, I mean, there's a need for a large specific surface to optimize the contact with water, but also to allow the breath, if we can use this name, because obviously it's not really a breath, but at least the oxygenation. I don't know if it's the right word in English, but the oxygenation of the plants. And all of this, let's say, faults due to the optimal specific surfaces of the plants creates very interesting cavities and very highly protective micro ecosystems for the fishes. So basically what matters is trying to reproduce that when it comes to artificial reefs. So there are different kind of artificial reefs and different techniques. The way we did it before was like this, with this kind of concrete block, I mean, a kind of traditional way, super cheap, by the way. It doesn't work really fast to colonize this kind of artificial reefs, but on the long term, let's say it becomes not that bad, but it really takes a lot of time to be colonized. With this big block of concrete, it's also the same kind of problems. Obviously, if the concrete is porous, it's already a bit better, but the porosity sometimes is also too small, let's say, for creating interesting cavities for the fishes. So it's either, let's say, the holes are too big or too small, because that's a material. So an ideal solution would be something like this sponge here, you know, by the way, which is also fixated.
It happens. It happens.
Yeah.
Okay. Okay. It's a shame because it's beautiful work you're showing us, Philippe. I'm sorry about that. Okay, I think the team is just we're live streaming again. Okay, my apologies. Yeah, do you want to share your screen again?
Yes. So, as I said, the problem with this artificial reef is that sometimes they are too massive, and there's not enough folds, let's say. So there are holes, and the hole is not a fold, and these holes are either too big or far too tiny because they are related to the microstructure of the material. So one solution would be to have something which is similar to this sponge here and reef. So there have been some experiments with 3D printing, for example this, which hasn't been done by yourself. By the way, it's has been done by an Australian company called Reef Design. And some other solutions, of course, were like using boats or sometimes voluntary putting boats in the sea, swinging them so that they would create artificial reef. But obviously, it's not a really good solution, even if metal is kind of okay, but sometimes most of the time there's paintings and many other chemicals which are not so good. The worst solution, of course, is putting tires in the sea, which is, yeah, it's definitely not a good solution. As you can see here, it's super cheap, but when we think of it, it's really a disgusting method. So recently, thanks to 3D printing, there is a possibility to overcome this, let's say, this limitations of the existing techniques. And one of the interesting applications for these reefs, here it's an example by, also by the way, by the Reef Design Australian company. But as you can see here, there's not a lot of fold, so it's more a kind of three-dimensional structure, which has a bit of texturing, but it's not that efficient. Here, it's an example from D-Shape, created by Enrico Dini recently. This is something which is quite interesting. It has been produced in 2012. It works quite well. It gives some really interesting results for fishes and other living things. Other experiences are this one, making use of like, some sort of clay, which obviously is cooked, so it becomes solid, as you can see here. So those things are quite tiny, but they also gives really interesting results. And another paradigm is this one. It's printed by the way by an ex-student of mine, whose name is Jim Roney, with his company So Liquid, which is about 3D printing in a gel, 3D printing concrete in a gel so that you can obtain three-dimensional structures. So my company has worked on that recently. So I make it really fast. So this is a company I created like 5 years ago. And as you can see with 3D printing, we can obviously create highly intricate patterns. And one of the applications for the, I mean, here obviously the intrication was not an end in itself. It was just a way to reinforce a mold for this concrete piece. But obviously, one of the potential application of that is the artificial reef, because as I mentioned before, it gives some very interesting specific surfaces results. So yeah. And like two years and a half ago, there was a first experiment in the south of France with the city of Agde, who wanted to make an experiment with XBoost, which is a company specialized in that. And as you can see, it gives some really interesting results with a very fast colonization of this reef, as you can see here. Another experiment was for Monaco. It's small habitations for the Meru fish. The Meru fish is a very specific kind of fish, which is rare, but extremely important in the local ecosystem. And one experiment was to put in the deep sea these artificial reefs. So here you see fabrications of that as well. And finally, another experiment also in Agde again, which this time was much more massive, is about fabricating 32 navigational markers, and to use these markers as, I mean, they are not the markers themselves, they are the weight that allows the marker to stay in place, obviously, next to the shore. And these 32 navigational markers were put into the sea with a gigantic crane, as you can see here. Giving again some really interesting results. So I might have a small animation, sorry, a small video here that I can show you. So if we want to have the sound, I need to just unshare and reshare with the sound because I forgot that, sorry. Okay. Yes, now there should be the sound.
Construction donc d'un X-Reef à
Voilà. Alors ils sont
Alors les voilà,
la grosse
le X-Reef.
C'est la partie socle, donc qui va servir au ballast du module. Le module imprimé fait 550 kg. La partie socle va permettre de rajouter socle plus poteau, de rajouter 900 kg. Et on arme cette partie, ça va aussi nous permettre de reprendre les efforts de la bouée de balisage et de les transmettre sur la structure pour que l'ensemble soit stable.
So it's basically a structure which is a bit more than 1 ton.
Des efforts qui vont être engendrés par la bouée des 300 mètres.
Ok, et de l'autre côté, donc là, de ce côté-ci.
Là, il va y avoir une partie coulée aussi le poteau, et ça, c'est l'anneau qui va servir à l'accrochage de la ligne de mouillage de la bouée. Voilà. Et ça, c'est l'accrochage de secours qui sera aussi armé avec des barres en fibre de verre pour retransmettre les efforts. qui permettra aussi éventuellement d'accrocher des choses sur le récif ou de le lever au cas où il y a un souci avec la moto.
Ok, merci Alex de C-Boost.
C'est des systèmes de connexion, des raccords d'assainissement. Et jusqu'à présent, les entreprises utilisaient ça pour faire des récifs artificiels, donc c'était déjà tout fait. C'était censé pas être très cher, mais au final, quand on regardait les coûts globaux en immersion, en transport, finalement, on arrivait à des coûts qui étaient quand même très très élevés. Et derrière, on n'avait pas les fonctionnalités écologiques qui nous intéressaient nous en tant que gestionnaire d'un espace maritime sur lequel on voulait augmenter la biodiversité.
So basically, these elements were finally used. Sorry. Can't. As you can see here, it was finally put in the sea a bit less than a year ago. 32 elements. So yeah, that's it. It's very short, but
Thanks. That was great. I wonder if, fantastic. Colin, do you want to put some on the background? Just put some coral on the background while we have some questions, one of your videos or something, or just a visual to.
Okay, I just need to be, I think, given screen sharing.
There we go.
Okay. And there was some questions over in the chat that I was kind of answering that maybe might be of relevance, but I can, let's see here. What I mean, what specifically, just sort of as background, or do you want
as background? I mean, this stuff is so exquisitely beautiful. It's nice just to have it there while we can just let
the homepage run on its loop. Yeah, there was some. Well, first of all, I think that everything Philippe is doing is really amazing, and I think that the development of the 3D printer and the ability to create much more complex structures is really an exciting future for this technology, and really an intersection of science and art and technology all happening at the same time. So this is something that I see, and I'm really excited that FIU is in my previous work with both Neil and Eric, kind of really revolve around a lot of this. And now we've got this collaboration with Madco 3D printing, which hopefully, Philippe, we can connect you with, because they have the same type of printer that Enrico Dini, I think it was made with him, and it's here in the United States. So it's not just an extruder, but can create really complex structures. And hopefully that's something that
that was sorry, that was what I was showing at the very end. Some early rough 3D print versions that with Madco 3D. They're huge printers, which, like you say, they are not just extruders of toothpaste, but they can do ultimately complex, full-on sculptures of big size.
Yeah. But maybe it's good also just to give an overview here. This is a map made by Miami-Dade DERM, Department of Environmental Resource Management. Miami-Dade has the oldest and I think the largest artificial reef program in the entire world. Of course, it was helped out in the 80s whenever there was a big drug bust, they would take the commandeer the ships that they were on and bring them offshore and sink them. So a lot of our artificial reefs are shipwrecks, which, as Philippe mentioned, they may be interesting, I think, for divers, not me so much, and for fishermen, because that's another thing that, artificial reefs have long been deployed just as places for people to go fishing, maybe in deeper water where you can't access them through diving. But it is something here in Miami that is really, is one of our legacies. And there was some questions in the chat about, well, where do you put an artificial reef? How do you don't want to ruin the environment, by altering it, which, sometimes people's good intentions wind up having negative impacts. But, it's important to keep in mind that most of the seafloor, even, in tropical areas is still just sand. And sandy areas, they're two-dimensional habitats. So again, thinking about why is there so much life in a coral reef? Well, that's because there's this three-dimensionality. But if it's all just sand, there's never that nucleus. There's not that seed for the first coral to start growing. The sand's constantly being churned, and so no coral can ever really grow there. But as soon as you put a structure of decent size in that sand, the fish will immediately start to aggregate around it. Within an hour, they will be on any new structure that you put underwater. And it's I think it's helpful to think about it kind of like a party. In Miami, it's never cool to show up early to the party because when you do, there's nobody there and you feel very awkward. You're all alone and you feel vulnerable. And so people, when a party gets started, oftentimes they're hanging out around the walls and that's exactly what a fish is going to do. If you put it in an empty box, a fish is going to cower in the corner. But as soon as you put something that makes it feel comfortable, then they start to aggregate around that. And then other fish say, hey, I see those fish are comfortable, so I'm going to go hang out with those fish too. And before you know it, you've got a whole community of life. And then, that's where suddenly, the waste from the fish is providing the fertilizer for the sponges and for the corals, and next thing you know, it's like a positive feedback loop. So a lot of the seafloor off of Miami is just sand. We have 3 series of reef tracts here. We have the first reef tract, which is pretty much right offshore. In fact, most of it's been buried under Miami Beach. So can you see this shallow line right here? This is Fisher Island here. This is your first reef tract. And of course, if we went back in time 100 years ago, these were connected. Fisher Island was not an island. And the reef tract would have been underneath what is now Miami Beach. But then the second reef tract is offshore, probably pretty much like right where these artificial reefs are out here. This is about 25 feet. And then you have the third reef tract, which is about 60 feet to 100 feet. And these are actually the ancient coastlines of Florida. When the sea level was much lower, then the corals were growing at shallower levels closer to the shoreline. So all the corals that are growing on the first and second and third reef tract in Florida, I mean, these are basically they're dead reefs that corals are now growing on, the recycling reefs that previously had been out of the water and then got resubmerged. But between those reef tracts, you've got a lot of sand. And that, I don't want to say it's wasted space because there's a lot of marine life that does live in the sand. But, compared to a coral reef, it is very, very low biological diversity. So adding structure to these sandy areas is a great way to increase biological productivity. And even if there aren't necessarily corals immediately growing on these structures, you're still providing a habitat benefit, and you're creating new places for fish and other organisms to live. So, there are, in my opinion, the benefits greatly outweigh the negatives, but, there have been instances, like Philippe mentioned, where people were using tires, and, there are materials that are not appropriate, and, we have to learn from our mistakes as humans try to do.
I've got a couple of questions.
Yep.
One for Philippe. Having tried out this thing on this beautiful work, by the way, beautiful work. Having printed this these artificial reefs, was there any feedback loop? Did you kind of like do some observations on where the coral was kind of aggregating most, or?
Yeah, in fact, there were a lot of scientific analysis looking at, with really precise monitoring for all of this. But this has been done by by third parties. So it's not something that has been done by the company. The company just printed basically and the things, but the monitoring was made by external scientists, and in fact also mostly public institutions or cities. But no, yeah, it was not done in-house. But for sure, all the feedback were extremely good. Extremely good. The efficiency of highly intricate and highly folded structures are just like is just like amazing.
And also, I'll mention that another kind of benefit of an artificial reef, particularly 3D printed or artistically designed reefs, is that it creates an alternative for divers to go and visit.
Yes.
So in other words, just ecotourism of people going to the natural coral reef and diving and snorkeling takes a toll on the natural reef. And Florida has probably got the oldest coral reef dive tourism, and we've got the most degraded reefs, and the most degraded reefs are the reefs that are the most tourist dived. And so if you can create alternatives where people are interested in seeing unusual structures and art and sculpture, in my mind, that helps also by alleviating a certain amount of pressure off the natural reefs. And to that point, in Agde, the place in France where you did your deployment, yes, about maybe 12 years ago, I made a pilgrimage to that site in search of, they're called jewel anemones. They're a type of corallomorph that are native to the Atlantic and the Mediterranean. And they had, when I was there, they had some small shipwrecks that had been sunk there because I knew the curator of the aquarium there, and he told me this is a place where you can find these organisms. And so I literally made a pilgrimage specifically to this site to dive on these artificial structures, to take pictures of these tiny little sea anemone corallomorphs that I'm so interested in. And that's the sort of thing that, that these structures, I'm sure, will become colonized by. And it's, it's a demonstration of if you can create things that are human engineered and are interesting and artistic, but also have the marine life in mind and maximizing the potential for that it's really a great way to accomplish all of these goals, both biological, scientific, and artistic. So there's a good reason to try and draw people away from the natural reef to an alternative that, still can be interesting, but helps to lessen that pressure.
Yes, I totally agree with that.
We got some other questions. I think it would be nice if Anna would like to ask her question. She's in Australia, where, of course, the Great Barrier Reef is important.
Yeah.
Just one question before maybe I quickly slip in is, one thing that I find intriguing is, on the one hand, the corals are very kind of susceptible to all these different kind of questions. At the same time, they've been resilient. I mean, they've gone back, and the dinosaurs never survived, but they've survived. And I'm just wondering, whether we might, I mean, just speculating whether they might be more resilient than we think. And I'm just wondering whether, if we do get sort of temperature changes and so on in the oceans, whether they're going to corals will start developing in other spaces, in other conditions.
I mean, the short answer is yes and no. It seems that they are clearly adapting. The question is whether they can adapt fast enough based off of how fast we now are increasing the temperatures and ocean chemistry. And it appears that we're doing it, that these are changing faster than, any previous changes. I mean, obviously a meteor out of space crashing into the Earth is an instantaneous, change in climate. But I think what is really necessary, and it's really kind of the crux of what Coral Morphologic tries to get to, is like, if you look at a coral reef, the takeaway that you get is symbiosis is good and important, and it really helps a lot of life sustain itself in a small area. And humans are, we're building in density. And as much as we talk about climate change and global warming as being the existential problem, I mean, really, we also we're not thinking about the, human growth, population growth, natural resources that are limited, all of these things, which are also, we're building in this density. And so symbiosis is important. And I think that the future of coral reef biodiversity, for the protection of that biodiversity, there has to be a symbiosis with humans. Humans and corals have to be symbiotic with each other the same way that a coral is symbiotic with its algae, because I can't imagine life on Earth, to be born on a planet 100 years in the future where all of the coral reefs are dead seems like you're going to live a life of depression right out of the gate. How can you possibly feel fulfilled as a human knowing that you were born into a planet that was destroyed before you had any opportunity to turn around the problem in the first place? So I think about future generations and what they themselves will be inheriting. And so, we have this connection where human health, our mental health, our physical well-being is dependent upon having a healthy Earth. And so corals and coral reefs sort of being these very sensitive canaries in the coal mine, if we can work to protect them, then we're working to protect all of the other, biospheres. But at the same time, I think, as much as it would be great to return everything to the way things were 100 years ago and nature could just sort of heal on its own, like that would be great. Unfortunately, I think, humans have altered things to the point where the protection of this biodiversity is going to be dependent on a certain amount of human development, whether that's creating laboratories on land where scientists are growing corals and spawning corals and doing very high-tech things to keep them, in an environment where we can keep them growing, because that's something, corals can live forever. I mean, this is something, because they're clonal, you can just keep taking frags and do it forever and ever and ever. That's something that means that we can protect all of this biodiversity if we just try. If we do it, we can. We have all of the technological capability of doing it. It's not cheap, but again, can you put a price on the health of the planet? It's a priceless thing, because as I said, if we let it slip, then everyone's future mental health is entirely tied. I mean, just this past year of the pandemic, how much of our mental health, is related to these feelings of well-being, the disconnect we have from each other. Like, it's all happening right now. We're experiencing the first wave of because pandemics are a part of global warming, they're a part of climate change. These are all things that are predicted. They're all expected. If we have more humans interacting with wildlife, whether it's in wild meat markets or just, encroachment into nature, we're increasing the possibility of new virus outbreaks and all of these things. The pandemic that we have in the ocean with the corals dying in South Florida over the past 5 years, that's directly the same issues that we're dealing with as a species. So we have the same problems. Humans are really just, I would say, the only ones. We've engineered a problem. And the question is whether we are going to be able to not only engineer our way out of it, because you can't just brute force engineer your way. You have to change the way that we think about ourselves and our planet. And I feel like we have for so long been on this idea that we have limitless natural resources, that the earth just kept getting bigger and bigger, right? There was always more to explore. There was always new territory left to discover, new resources to tap into. And we've crossed that point, a while ago. And now, fortunately, we have at our disposal, we're living at a point in time that's so exciting that we know how old the universe is. We have a map of the universe. We understand how the physics of the universe works, and we understand that the physics here is the physics, across the universe. But it's at the same time, we're also realizing that this great human understanding has now developed sort of, it borders almost on a cancer where we become our own enemy. And now we need to check our entire, the whole paradigm of the future needs to shift. And I would like to think that coral helps do that by changing our perspective of space and time. So you think about, and then all of a sudden, the discovery of the New World, the European discovery of the New World, and the sort of the realization that we, in fact, were not the center of the universe. It decentered ourselves to realize, wait a minute, we're going around the sun. This is when it's really difficult to do that, to think about timescales that are millions of years. And, in a million years is nothing. That's just a blink of an eye, really. For, we talk about corals recovering after previous extinctions, that recovery could have taken millions of years. And so, we humans are very selfish, maybe to our own detriment, because we almost are living in a time, and then maybe we change the paradigm, and then people really start thinking over this longer term, thinking about future generations.
I'm guessing that what happened over the pandemic was the cruise liner industry shut down. Were you able to discern, I guess, any noticeable thing with your underwater camera that was recording everything? Did you see any difference in terms of marine life?
Yeah, well, it's unfortunate that we didn't have the camera in, say, a year before, so that we really had like a whole year to see, what the previous baseline is, because it's tough to know, are there seasonal changes in abundance? Because, in the winter, the water's colder, it's migratory species and things like that. So it's, the thing is, though, is that the cruise ships have still been active. They're still coming in and out of Port Miami because they're fueling. They have, a skeleton crew on them. They're still operating. They're still burning. To me, one of the things that's so crazy is that when these ships come to Port Miami, Miami doesn't have smokestacks. We don't have industry. We don't have air pollution. So, we have cars, we have air pollution, but we don't have the type of industrial pollution that you associate with, Rust Belt cities. And these cruise ships come in and they're burning the lowest grade fuel that you can, because they typically are burning it in international waters. And the port doesn't provide them with shore power. They could connect to electricity to the port, but instead they just sit here and they burn. They were just burning. You can see the smokestacks, which to me is totally insane. That it's a perfect example of green jobs, trying to switch people. Let's just get these cruise ships to not be burning all this fossil fuel right here where we're all breathing it. So, the cruise industry is they're not always the best neighbors, but there are bigger problems, I would say, also.
Great. Let's have some other questions. Anyone? Any questions? I don't know whether, Anna, you wanted to ask one from Australia.
Yeah, I was just wondering if there is somewhere we can find data between the relationship between the coral growth or the reduction and the increase of the sea level?
The actual like sea level rise and
level rise and then the coral growth, or
so I'm not sure where one can find that. I think what you're alluding to is that, you know, corals and reefs can grow a certain amount per year, but we're also dealing with a certain amount of sea level rise that's happening each year. And if sea level is rising faster than corals can grow, then in theory, you know, we can lose reefs because the sea is rising too fast. I think that's, you know, it's the rise in temperature, which of course then melts the ice caps, which then raises the ocean levels, is in my mind really the bigger existential threat. I would say if we were in a situation where the sea level was going down, corals would have a much bigger problem, right? So that's also something we tend to forget, that the sea level rise is a human problem, not a coral problem. We might couch it in terms of, well, we should do it for the corals, but really we're talking about our real estate, right? Every time the sea level rises a foot, we lose the most valuable real estate that there is, which is the coastline. So when we talk about the coral city and we say, hey, you know, we need to be thinking about the future of Miami because corals used to grow here when it was underwater and they will grow here when they come back. So, you know, we're really kind of more ambassadors for the corals themselves. Like, the corals are just waiting to take over our city. They will take our infrastructure. They're on our doorstep, right at the low tide line, just waiting. So, you know, the things that are human problems are not always the same that are coral problems. So in my mind, coral can grow upwards, and coral can lives to up to 100 meters deep. So, you know, rising 3 meters, a rise of a meter to a coral is no big deal. A rise of a meter to humans is a real big deal.
Doesn't it affect the amount of light for the...
It does, but not at all to the extent that the coral itself is going to be affected. In other words, you know, coral is highly adaptable to getting direct sunlight, but sometimes, you know, there's other parts of the coral colony that are barely getting any light at all. So, I mean, yes, one can say that, okay, a rise of a meter does reduce the amount of light that the coral is getting, but okay, a rise in a meter of sea level rise, even by the sort of the worst case scenarios, we're talking about, I think, probably at least, you know, 50 years or so, which for a coral, you know, it can handle that. And because keep in mind that for every, if you're flooding the coastal zone, then for every bit that you're losing of real estate because it gets too deep, you're opening up probably more real estate in the shallow area for coral to grow in the future. So it's a trade-off. But the warmth, the global warming that melts the glaciers that causes the sea level rise is the bigger problem.
We just want one thing, Colin. Apparently, we've been blocked on YouTube because of copyright reasons. So maybe we could change the screen for a second. I don't know if that was our original problem, but
no kidding. That's weird because there's no sound. So it's strange that. But I guess you know, it is a
we had that problem.
Copyrighted work.
Yu Yang, we got Yu Yang in Beijing, who is. She teaches us here in maritime architecture and these things, and she's going to ask a question. Yu Yang?
Hi, thank you, Colin. And I'm so impressed with today's lecture by all of you, and especially for the coral issue. And Actually, we opened a class which is focusing on the marine issues. And we also mentioned on the coral issue. And we have been showing to our students some of your cases already as a reference. So I'm so excited to see the real cases here today. So I was, for our classes, we are share the problem with the white dolphins. They are living in Hong Kong ocean area, and they're also affected by the a lot of problems such as fast road and noise hazards, water pollution, and underwater engineering constructions, and so on. So we are working collaborated with WWF, Hong Kong and Shenzhen, and they supported us with like the knowledge of the situation right now with the marine lives and the situation. So it helps us a lot. But for coral issues, we're not have been focusing a lot on it, but we're planning to working on it later. So I was so curious about the design process of the structure. Is that necessary for different locations to design the different types, and the materials is also depending on the areas that you choose, because sometimes we need to put them nearby the sand area. Sometimes we need to go into deeper the ocean. So I was wondering about the technical design process about this problem. I don't know if I'm clarifying myself. Thank you.
Yeah, I think I'll say something and then Philippe probably has something to say, but in general for artificial reef deployment, like in the state of Florida, you can't put an artificial reef on existing reef habitat or hard bottom or seagrass. Pretty much you're restricted to sandy areas. So that'll be, something, because you don't want to ruin an environment that already is quite productive. So sand areas are usually the best place to do that. Presuming all the other parameters are, just because you put an artificial reef in place, if there's pollution nearby, just because you transplant corals there, the corals might not survive. So you're still limited by the actual parameters of the water around, which is something that, I'd say before you do an artificial reef project, you really would probably want a year, if possible, of kind of studying the physical parameters of the site. How hot does it get in the summertime? How murky does it get? Because really murky areas, then you're not getting light for the coral. Like here around Miami, in the bay, where we have these urban corals that are growing on the riprap and the shorelines, they're below about 10 feet. You don't really find too many corals, and that's, I think, because of the water has turbidity and sediment and algae that blocks a lot of the light that the corals need. So they tend to just be growing below the low tide line to about 3 meters in depth. But Hong Kong is another place like Miami that is, I would consider, a coral city. Singapore, Hong Kong, Sydney is also has corals growing in it. It's a little bit outside of the tropical area that you typically find corals growing. But I always like to connect what I consider sort of sister cities, and Miami is I consider Hong Kong and Singapore to have very sort of similar opportunity. I've never been there, but I know that that it's a place where you still can find marine life and impressive marine life. So I'd love to see other projects like that are not just also corals, but all these things. Here in Miami we have manatees that we have to be thinking about. Boats are easily strike manatees. But dolphins are also, all the marine mammals. I can't imagine what it's like to live in a world with the amount of sound underwater, people often ask us, well, why don't you have a hydrophone on the Coral City camera? I want to relax to the sound of, you know, the underwater. And I say, you don't want to listen to it, because it's like a industrial noise album. It's very jarring, and the way that sound moves underwater is much more, it's faster than in air, and things travel. So, you know, these mammals that utilize, like dolphins, they utilize sound as a way to communicate and a way to navigate, you know, the world of sound pollution that we've created for these environments is something that doesn't get a lot of thought about, but it seems to be quite important for these marine mammals, with whale strandings and things like that, perhaps related to underwater acoustics.
Thank you, Colin. I do agree that the coral is a very important key to the life cycle in marine life. Okay, thank you.
Yeah, you're welcome.
Do we have any final questions? This has been absolutely brilliant, Colin, and thank you so much. It's really, it's just a beautiful combination of it reminds me of going to outer space. I mean, when we went to outer space, we saw the blue marble image of Earth, we realized how delicate our ecology was. And also sometimes going underwater, you get the same kind of perspective on life.
Absolutely. I think, you know, one of the things that excites me the most about, you know, I mean, Elon Musk is an extremely, you know, just has lots of really amazing, huge ideas and has done amazing things. You know, he's got his sites on Mars, right? And it reminds me, like you just referenced, you know, back in the 60s when we were trying to go to the moon, everyone had their sights on the moon, and how great we would feel when we achieved reaching the moon, and what a great accomplishment for a species. And really the thing that was this paradigm shift, you know, talking about these moments where there's a realization was the Earthrise, you know, where the astronauts turned around and looked back at Earth and had the sort of a spiritual experience of realizing just how amazing this planet is. And one of the things that excites me, based on what we've done with the Coral City camera, is, you know, SpaceX is now launching satellites that will provide global internet coverage. And if we can get global internet coverage to remote places like the Great Barrier Reef and, you know, islands in the middle of the Pacific Ocean, where suddenly we can utilize cameras so that people all around the world can observe nature in real time, that's the type of empathy that makes people feel connected. You know, it's really easy to feel disconnected from an environment that, you know, you can't get to, or requires a lot of money or you know, expertise to go and visit. You know, what I've noticed through the Coral City camera is that it really has connected people to nature in a way that they never thought imaginable. And this is just right here in the city. And, you know, like, you know, we're not using satellite internet, we're utilizing, you know, we have good internet, you know, we're right in the middle of the city. But I think that this idea of going to Mars and all of this money that's being spent to develop space exploration, that really maybe the most important thing to come out of it will be these tools that enable us to observe and appreciate our own planet more than ever, which, you know, hopefully the satellite internet. And I'm hopeful that this will be a desperate change in how we can protect environments. Because imagine, you know, when all of a sudden you've got school kids that are, you know, protecting herds of elephants from poachers, you know, or they're flying drones to you know, protect you know, certain places. Like, I think that you know, it's sad to say, but gamifying, you know, everyone sort of treats life as a game anyway, and, you know, it's like the name of the game is save the planet, you know, so we have to gamify it in any way that creates a positive feedback loop that makes people feel better, that gives them the serotonin or the dopamine that says, I'm doing good, this feels good, and you're protecting something at the same time. That is, in my mind, what it's going to take to get people fully engaged and make, you know, the most popular game to play is called Save the Planet.
Colin, we're going to have to wrap up now, but this
Sure.
is absolutely brilliant. And I want to thank you for, I mean, first of all, I got to say, every morning when I wake up, I'm aware of you because I have some photographs, some coral morphologic on my wall. So absolutely exquisite. And my family back in England has it as well because they got a Christmas present from you for those photographs and things of your work. So absolutely brilliant. And I think this is kind of to be continued. It's great to sort of to really keep this discussion going, and it's fantastic to be able to introduce Philippe to you, and you can see what's been going on in France and so on.
Great work.
I just think you really articulate, I think, something about Miami as this being absolutely unique ecology that is very special and I think you've done a lot to kind of highlight awareness of the importance of the environment as well alongside that. So and it's strange. One thing I find, let's say, is you would strike me as being kind of like a very similar to an architect. I know that you've got some friends working in the world of 3D printing. I'm forgetting the name of the guys in Boston. Anyway, but you kind of the combination of kind of the art world and the scientific world together is quintessentially architectural, and also the idea of morphogenesis and learning from nature has been central to a lot of discourses going on in architecture recently. So thank you. Any final comments from Philippe at all?
No, I would thank you, Neil, also for this connection, but also for setting this lecture about Miami. The funny thing, but I will show you that someday, is that I always consider the whole ecosystem, but also the urban structure with the water all around in Miami as a model for the future, but not, I mean, really a kind of global model that could be applied to the scale of the Earth. And I will show you some drawings I made about that in like 2002, 2004, and later when we will have time. But I think this Miami Urban Studies series is super interesting, and I was really happy to discover the work of Colin, and also to learn quite a lot about this specific ecosystem. I mean, many things I don't know because I'm definitely not a marine biologist.
That's great, and and that's one of the roles I think that I try to play, and Coral Morphologic tries to play, is kind of helping to bridge the communication gaps between scientists and between artists and between architects and city planners and everyone in between to sort of understand this hidden language of the coral that has so much to teach us, I think.
We'll have to wrap up. I would love to go on forever. This is fantastic, Colin. I really
thank you, Neil, for having me.
Thank you, Colin. Thank you.
And hopefully, this is something that will continue with FIU really being kind of at the forefront of this intersection of reefs and architecture and science and art and having it really make Miami the place for these types of ideas to take seed.
I think this is just the beginning. I absolutely. I would love to introduce you to Philip Beasley, his Living Systems community as well. I mean, I think there's a lot of overlap here, and I think some of the students also are fascinated by this. I know that Anna in Australia wants to write about this and the Great Barrier Reef, and maybe even Theodore is interested in kind of the possibility of modeling. He's an AI expert to work on the modeling the growth of coral in the way we never achieved in the past, but I think it's just beginning. So thank you, everyone, and thank you, Colin, especially. This is going to be carry on forever, to carry on more in the future. So yeah, I can't say it more, but thank you so much. Thank you.
Yeah, cheers. Have a great day, guys.
Okay.
Thanks a lot.
Thank you.
Thanks, everyone. Bye-bye.
Bye.
Thank you.
Bye.